Everyone, so I'm back with another question. In this question, we are given a number which is represented by linked list. So what does that mean is each node of linked list represents a digit of the number. What we need to do is just double the number and represent it as a linked list and return that linked list. In this video, we will discuss two ways, which the first one have a space complexity of O of n and we will decrease it to constant space in the second approach. For this example, if we multiply this 189 by 2, we will get 378. So what we have to return is a linked list which is representing this number 3, 7 and 8. Let's move on to approach 1. The approach 1 is pretty simple. What we'll do is we will place a counter, let's say m, which will traverse the linked list and we will make a number. So we'll make an integer which will take the first digit. For now it is 1. Then it will move to the second counter. Then we will update this answer by multiplying it by 10 and add the next digit. So that would become 18. Now our pointer moves to next this n, this 9. So we will again multiply this by 10. This is multiplication. Oh, sorry, this was addition only. And we will add 9 to this, which will give us 189. So that's what the representation, we have converted it into an integer. And now what we have to do is we have to multiply it by 2. So we will just take the answer, and answer is equals to 189 multiplied by 2. When we will do that, we will get our answer as 378. Now what's left is that we have to convert this number back to the linked list. So how can we do that is we can make, as we do a while loop, and in that while loop until this answer is not equal to 0, what we'll do is we will take a digit which will be answer mod 10, and then we'll have to divide the answer by 10 to get the next digit in next iteration. And as we are getting this number, we should add it to a linked list, or you can also add it to a stack, and later you may convert from that stack to the linked list, because we will see in the future that we need to reverse this answer. For making the linked list, we will need a pointer. Let's say this is our head pointer, or let's say head 2. Head 2 is nothing but a list node star. Okay. And initially it would be pointing to null. And as we have gotten the first digit, what we'll do is, so in the first digit that we get, our head would be null. So we need to check it. If my head 2 is equal to null pointer, that means our linked list is now empty. So we will just make a new node. Head 2 is equals to new list node, and that would be this digit in this iteration that we got. Okay. And if the head is not empty, we can make another list node, let's say temp. So list node star temp, and our temp will be nothing but a new list node that we want to add. So a new list node of digit. And if this has happened, so we need to continue the loop from here, as we don't want further computations in this iteration. Okay, so we will continue from here. And as we have made temp, now we have two choices. Okay, so let's say we have made our first node and we have gotten another digit that we want to add to this linked list. So you have two options. Either you can insert this node at the next of this node. That would be a problem, because not only you have to traverse from head to the end to the tail. So let's say if it had 4 nodes initially, then this node would be added here. So you might have to traverse it here, or you maintain a tail pointer here, another pointer tail, which would be always at the end of the linked list for making insertions. But if we look in this particular question, then what would happen is, for this 378, we will get 8 first, then we will add 7, let's say we are using the tail pointer and we are adding the node at the end, then we will add 3, but this is giving us the answer in reverse order, and now for getting the answer we have to reverse this again. So that would be 3, 7 and 8. That seems tedious. The better way to approach this problem is not by inserting at tail, but to insert at head only. So let's say we have this linked list and this is our temp and this is our head. So what we will do is we will just simply say that the next of this temp is equals to head, and then we'll update this head is equals to temp. So we have inserted this node at the head only. So what does that mean is that initially when our head was empty, we just made a head of the first digit, which is 8, and then what we did was in the next iteration we will get this 7. So our 7 is now in temp, and we will do temp.next is equals to head, and then our head would be pointed to this temp, which is 7. So we have inserted it to head, and now again when 3 comes, 3 will be inserted here. So we have made a linked list 3, 7, 8, and we don't need to reverse this linked list. So now what we have to do here is we have temp, so our temp next equals to our head, and now our head is equals to temp. So that should be head 2 because head was the head pointer of the original linked list. So we have named it head 2, and now finally after this while loop we will just return a head 2. So that was the first approach. Now let's move on to the second approach. In the second approach, what we are going to do is we are just going to follow how we naturally multiply numbers. So let's say we have this 1, 8 and 9 and we have to multiply it by 2. So what we do is we multiply this number by this, so that would be 18, and 1 goes to carry. Okay, so let's make it with another color. So 1 goes to carry. Now we again multiply this. So 2 8 is 16, 16 plus 1 17. So carry is added, and now again 1 carry is moved here. Okay, 1 carry is moved here. Now 2 multiplied by 1, that's 2, and then this carry will be added, so that would give us 3. Let's take another example. In this example, we will multiply a number like 999 by 2. So what would happen is that we'll get a carry here and our digit will be expanded by 1. So 18, 1 goes to carry, again 18 and 1 plus 1, so that would be 19, and again 18 plus 1 19, but we have no further digits, so that would be 1998. Okay, so how are we going to handle this operation in the linked list? It's not so complicated at all. So let's move on to the code. Before moving on, you must see that we are multiplying it from the end. We are multiplying this from here, but this is a linked list. We cannot access the previous node from the current node. So what do? We can reverse this linked list. So if we reverse this linked list like this, so we can traverse this linked list using a pointer from n to the first node. Okay, so what we are going to do here is we'll have a variable, let's say carry, and with each node we are going to multiply it by 2. So we are just going to do it in place. We are not going to make another linked list. So what would happen is that we'll multiply 9 by 2, that would give us 18. So how do we know if there is a carry generated? So a carry is generated when there is a 2-digit number. So if this multiplication, that is 18, is greater than 9, if it is up to 9, then there is no carry generated, but now 1 carry will be generated. So what we'll do is we will update this carry from 0 to 1, and this 18, as we have discussed in multiplication, we take only this digit. So how can we get this digit? Is by subtracting 10 from it. So we will subtract 10 from it and we will update this 9 to 8. So we have updated this 9 to 8. Now a pointer will move to this next node, and here we again multiply it by 2. We'll get 16. But now our carry is 1. So this would give us 17. And again this is greater than 10. So we will update our carry to 1, and it is already 1. But let's say we do it 1 whatsoever. And again subtract 10 because it is a 2-digit number that is greater than 9. So this would give us 7. And now our carry is 1, and we will move to the next location. So in the next node, we again multiply it by 2, we get 2. And we add the carry, we'll get 3. Now this 3 is less than 10, is less than 9, or that is not a 2-digit number. So what we'll do is, we will update our carry to 0. This is an important step. Not in this question because after this there is no number. But if you forget to set this carry to 0 again, in the next number it will be taken as a carry. So we'll set it to 0. And now 3, and our carry here was 1, which is already added in 3. So that would give us 3. So we have updated these values by 8, 7 and 3. So finally what we have to do is we have to again reverse this linked list, and that would be our answer. Now let's try to see the code while dry running this example where we have another digit. So let's move on to that approach. So in the first step, we will reverse this linked list. So reversing this linked list will give us again 999 because all the digits are same. After reversing the linked list, we will set a pointer temp which will start traversing this linked list from here. So now what we have to do here is we'll make a while loop until we reach this node. So why this node? Because at this node we need to check if the carry is there 1 or 0. If it's 1, then we need to add another node in the linked list, and then we will set the value to 1. We are setting the value to 1 because if we multiply any number by 2, that is any digit by 2, we will get 1 only, because the maximum number is 9 and we multiply it by 2, we'll get maximum of 18. So that's always going to be 18 if a carry is generated, so that would always be 1. So first of all, we'll multiply this number by 2 and add carry to it. Initially our carry is 0. Carry initially is 0. Now we will multiply this by 2. We will get 18, 9 multiplied by 2 plus our carry, that would be 0. So this will give us 18. Now this is greater than 18. So what we'll do is we will update our carry to 1 and subtract 10 from it, minus 10, that would give us 8, and update this value to 8. Now we'll move our temp ahead. In this, we will again multiply this 9 by 2 and add carry. Now it's 1. So plus 1, this would give us 19, and subtract 10 from it. So this would give us 9. So now we'll update this by 9 only. It is already 9. Let's do it. And now when we'll move to this number, we have our temp.next is equals to null. That would be the condition of our while loop. So as we have reached such node that its next is null, we'll break from loop. But if you look closely, the computations for this node are left. So outside the loop, we'll write it again. So what that would be is 9 multiplied by 2 plus our carry is 1. That would give us again 19, and it is greater than 10, so we'll update our carry to 1, and subtracting 10 from it will give us 9. So we'll update it to 9 only. But the better part is that now we have our carry 1. We have taken this out of the loop because we have to check this condition for this node only. So if we have our carry is greater than, or let's say is equal to 1, because it can be the 1 or 0. So what we'll do is we will make another node, and what we'll do is temp.next would be equal to a new node, and the value would be 1 only. So we'll add another node and the value inside it would be 1. So that would be our answer. But before returning this, we need to reverse this list. So reversing this list would be like 1, 9, 9 and 8. And if we look closely, this is what we got after multiplying this by 2, 1, 9 and 8. So I hope that you have understood this video. The code is attached in the description, both the LeetCode and the GitHub submission. So bye bye.